So that means that, just looking at this, if I had 10 times the sine of 2 times t, then I immediately know, okay, this is going to be the frequency, or how fast it is. So if I was comparing two different waves, like 10 sine 2t and 5 sine of 10t, so this is going to be the first angular frequency, this is going to be the second angular frequency, this is going to be the first amplitude, and this is going to be the second amplitude. I can immediately conclude this angular speed is greater than this angular speed. So this means that this wave is going to have a higher frequency or a higher pitch if it was a sound wave. And then this amplitude is less than this amplitude. So that means this wave is going to be, this wave is going to be much louder than this wave, right? So this is how to understand these equations. So there's one other thing though. If you think, okay, a wave is only about a frequency and amplitude, and that's true if you're just hearing one pure wave, but a lot of times people want to talk about a phase shift. So normally they add this thing called a phase shift, which is a delta here. And actually this is the simplest thing ever. Okay, you have the unit circle. Here, before the phase shift, you always started at 0. So the graph for sine of theta always starts at 0, and then it goes like this, right? Well, with a phase shift, it just says, well, we add on theta, right? Oh, we add on this delta. So instead of starting at 0, we will start at the angle delta. So that means instead of the sine wave starting here, it would start, somewhere around here. So at the 0 point, then it would actually start, here, and then the whole thing goes the same, right? It would be delta plus omega t. So then, this whole angle is just plus omega t, and just give a sine wave like this. And just the whole sine wave is sort of shifted over by delta. So like if you just look at this missing part that originally had it here for 0, this distance would actually just be delta. So this is what a phase shift does to the wave. It doesn't change the frequency or the amplitude at all, but it will shift the graph over a little bit. So for one wave, this phase shift is not actually very important, but for interference of multiple waves, sometimes it does become significant. One example is, so getting more into superposition of waves, but if you had the exact same frequency wave, and then one of them was going up like this, but the other one was sort of shifted over exactly 180 degrees. So that means this part became 0. So that means the other wave is going to be shifted exactly like this. And you can see if you add them, they actually directly cancel each other out. And so that means two waves of the same frequency can actually cancel each other out and create a 0 phenomenon. And this is, so I won't get into too much details, don't worry if it gets a little bit confusing. But it's about when multiple waves have the same frequency and then they're offset by 180 degrees or pi, they can directly cancel each other out, and that's normally called acoustics. And so it's when in some places of the room you can actually hear the sound. Actually there's two different ways. It's like you have a wall here. If the sound exactly hits the wall over here, then it is going to get reflected and then it's going to cancel each other out. However, if the distance from the sound to the wall is exactly so that the highest point of the wave hits the wall, then actually your reflected wave is exactly matched to the original wave. And it actually doubles the loudness because you add these two waves together and it actually doubles everything. So this is about acoustics and interference, and that's why the phase shift is important. But other than that, you can tell the frequency or angular speed by this, and then you can tell the amplitude by that. Just make sure one more thing is remember, we showed earlier that the period of a wave is 2 pi divided by omega, and then the frequency was 1 over the period. So if you just simplify this, then it means the frequency is also omega over 2 pi. So the frequency of the wave is directly proportional to the angular, angular speed or angular frequency. So you can also just treat this as a frequency of the wave.